Hello viewers, in today's session we are going to discuss some important problems related to finding out the higher order derivatives of functions. Right, so here we'll solve some important problems in which the higher order derivatives are involved. Right, so let us take the problems one by one. So let us first take this problem in which we are given e raised to 100 x square plus y is equal to x raised to 200. Then we have to show that x cube times the third derivative of y with respect to x is equal to 400. So here we are given this expression in which the power of e is 100x square plus y, and the right hand side is x raised to 200, and we have to show that x cube times the third derivative of y with respect to x. So we can also write x cube times d3y over dx3 is equal to 400. So here this derivative is known as the higher order derivative, and here the third order derivative is involved. So now to arrive at this result, what we will do, we'll take help of logarithms and we'll take the natural log of both sides. So we have natural log of e raised to 100 x square plus y is equal to the natural log of x raised to 200. So here we can make use of this property of log, that is log of a raised to m is m times the natural log of a. So here we have 100 x square plus y, and then we have log of e, and here we have 200 log of x, and log of e is equal to 1. So we have 100x square plus y is equal to 200 times natural log of x. So now let us differentiate both sides with respect to x. So we can now write d by dx of 100x square plus y is equal to d by dx of 200 times log of x. So here the derivative of x square is 2x, and here we have dy over dx, and here we have 200 because 200 is a constant, and here log of x. So the derivative of log of x is 1 over x. So we have 200x plus dy over dx is equal to 200 over x. And now we can take this term to the right hand side. So we have 200x 200 over x minus 200x, and this is 200, taking 200 common, we have 1 over x minus x. So the first derivative is given by this expression. So now to get the second order derivative, let us differentiate both sides with respect to x. So we have d by dx of dy over dx, and here we have 200 and d by dx of 1 over x minus x. So this is the second order derivative d2y over dx2, and here we have 200. The derivative of 1 over x is minus 1 over x square, right, and the derivative of x is 1. So this is the expression for second order derivative. So now let us differentiate both sides to get the third derivative. So we have d by dx, and here d2y over dx2, and here we have d by dx of 200 minus 1 over x square minus 1. So this becomes d3y over dx3. that is the third order derivative. And here we have 200, taking 200 outside this derivative operator, we have dy dx of minus 1 over x square minus 1. So this is 200, and the derivative of 1 over x square is given by minus 2 over x cube, right? And the derivative of 1 is 0. So now the derivative of minus 1 over x square minus 1 is given by minus 2 over x cube, right? So the derivative of 1 over x square can be written as d by dx of x raised to minus 2. So this is minus 2 times x raised to minus 2 minus 1. So this is minus 2 times x raised to minus 3. So this is minus 2 over x cube, right? So now the third derivative is equal to 200, and here minus times minus is positive, so we have 2 over x cube, that is equal to 400. 200 times 2 is 400, and this is 400 over x cube. So now we have the third derivative, that is y triple prime. The notation for this is y triple prime, and here we have 400 over x cube. Now multiplying both sides by x cube, we have x cube times y triple prime is equal to 400. And this is the result which we have to prove. So now let us take this second problem, in which we are given that y is equal to x cube times log of x, and we have to show that x times the fourth derivative of y with respect to x is equal to 6, right? So we'll start with this expression, y is equal to x cube over log x, and we have to find the fourth derivative of y with respect to x to get this result. So now differentiating both sides with respect to x, we have dy over dx is equal to d by dx of x cube log x. And here to get the derivative of x cube log x, we'll make use of the product rule by taking x cube as the function u, and log of x as the function v. So we have d by dx of u times v, and the product rule for differentiation is u dv over dx, and then v and du over dx, right? Okay, so here we have u as x cube, so we have x cube, then derivative of log x, and then we have log x and derivative of x cube, right? So this is x cube, the derivative of log x is 1 over x, and here we have log x times the derivative of x cube is 3x square. So here this x and this x get cancelled, so we are left with x square, and here we have 3x square and log of x. So the first derivative of y with respect to x is given by this equation. So now differentiating both sides with respect to x to get the second derivative, we have d by dx of dy over dx, and here we have d by dx of x square plus 3 times the derivative of x square log x. So this is the second derivative, d2y over dx2, and here the derivative of x square is 2x, and here we have 3, and again applying the product rule, taking x square as u and log x as v, we have x square, then the derivative of log x is 1 over x, and then we have log x, and derivative of x square is 2x. So this is 2x plus 3, and here x and x get cancelled. We are left with x, and then we have 2x log of x, and this is 2x plus multiplying these two terms by 3, we have 3x plus 6x log of x, so this is 5x, 2x plus 3x, 5x, and here we have 6x log of x. So the second derivative is given by this expression. So now differentiating again both sides with respect to x, we have dy dx of d2y over dx2, and here we have the derivative of 5x plus the derivative of 6x log of x. So here we can now write the third derivative d3y over dx3, and here we have 5 being a constant. We have the derivative of x with respect to x is 1. Here we can take 6 outside, the derivative of x log x. So now we have 5 plus 6 times the derivative of x log x. So taking again using the product rule, taking x as u and log as v, we have x, derivative of log x is 1 over x, then log x, and derivative of x is 1. So now this is 5 plus 6, and here x and x get cancelled. We are left with 1 plus log of x. So this is 5 plus 6 times 1 is 6 plus 6 log x. So this is 11. 5 plus 6 is 11. 11 plus 6 log of x, right? The third derivative is given by here 11 plus 6 times log of x, right? Now here we wish to find out the fourth derivative. So again differentiating both sides with respect to x, we have d by dx of d3y over dx3, and here the derivative of 11 is 0 because 11 is a constant, and here we have 6 times the derivative of log of x. So here we have the notation for fourth derivative as d4y over dx4, and here we have 6 times the derivative of log x is 1 over x, so this is 6 over x, right? So multiplying both sides by x, we have now x times d4y over dx4 is equal to 6, and this is the required result which is to be proved.